All right, here it is. We are talking properties of parallel lines. We talked about 4 different types of angles yesterday, right? We talked about what? What were the 4? Corresponding angles. Alternate interior angles. Same side interior angles.
Same side exterior.
Alternate exterior. But there are same side exteriors, so you could go with that. So I'm going to give you 4 theorems that go with those 4 angles. And I think we're kind of just going to do all of them in one shot. And then I'll do some examples of what you can do with them because they're all very similar. So we're going to start with same side interior angles. That's an M, not an N. Same side interior angles postulate. Okay. Rather than give you a whole bunch of words, I'm going to give you some words, but a picture and then kind of a setup that goes with that picture just to help you kind of visualize it and get the idea. So let's say we have these 2 lines. We're going to call them line A and line B, and then we have this transversal. Okay, and they're going to tell us that these 2 lines are parallel. So whenever they put arrows on the lines like this, that means they're parallel. Okay. If we have all of these angles, okay, the same side interior angles postulate says if A is parallel to B, then same side interior angles are supplementary. Sorry, I ran out of room. So if A is parallel to B here, then same side interior angles are supplementary. In other words, what are my same side interior angles here? 4 and 6 or 3 and 5. So I could say the measure of angle 3 plus the measure of angle 5 equals 180. And I could say the measure of angle 4 plus the measure of angle 6 equals 180, okay? So this is true if the lines are parallel. If A is parallel to B, then same side interiors are supplementary. And what I want you to hear in that is the S's. Same side interiors are supplementary, okay? Of all of the angles, this one, same side interiors, is the only one that starts with S. It is also the only pair that is supplementary. So keep that together. Same side interiors are supplementary, all right? So that's the first one. We're going to use that same picture for the next one. The next one says, and this is the alternate interior angles. Alternate interior angles theorem. Okay, this one says, using the same picture, if A is parallel to B, then alternate interior angles are congruent. Okay, so alternate interior angles are going to be the same. So if you look at this picture, what does that mean? Give me numbers. What angle congruent to what angle? Yeah, Sam.
3 and 6 are congruent.
Right, so we can say 3 is congruent to 6, and we can say 4 is congruent to 5. Okay, so same sides are supplementary. Alternate interiors are congruent. What would you guess is true of corresponding angles? Correspondings are also congruent. So for this one, we would say if A is parallel to B, then corresponding angles are congruent. Okay. So give me some numbers. What numbers are congruent in this picture? Yeah, Sam.
1 and 5.
1 would be congruent to 5. Or 2 would be congruent to what? 6. Or 3 would be congruent to 7. Or 4 would be congruent to 8. Right? So if lines are parallel, notice that every single one of these starts with if the lines are parallel, if the lines are parallel. Same thing on the top one, if the lines are parallel. So as long as the lines are parallel, then these angles hold true. The correspondings are congruent, the alternate interiors are congruent, the same side interiors are supplementary, right? So there's 3 of the 4. And then the last one of the 4 is alternate exterior angles. I'm going to make it a little smaller so you can still see my picture up there. So for this one, it's, oops, get my pen back. Alternate exterior angles theorem. Okay, and this one again says if the lines are parallel, then alternate exterior angles are, what do you think those will be? Congruent or supplementary? Alternate exteriors. They're congruent also. If the lines are parallel, then alternate exterior angles are congruent. So if we're looking at our picture again, we would say that angle 1 is congruent to angle 8. And we could say that angle 7 is congruent to angle 2. Okay, so those are the 4 theorems. Notice what happened. In our 4 theorems, every one of those angles was mentioned, right? So the beauty of these types of problems is if you know one angle, you know all the rest of them. And I will show you that in just a second. But keep that in mind. All you need is one, and you can figure out the rest, okay? Can I move on from this? Yeah, Sam.
Why is the first one a postulate and the other's a theorem?
Oh, great question. Postulates are just accepted statements of fact. Theorems are things that had to be proved. So for some reason, that is accepted as fact, whereas the other 3 had to be proved theorems. I don't have a good answer for you for why that one was a postulate and these are theorems, but that's what postulates versus theorems are. So, okay, let's do an example here. Let's say I give you these 2 lines with this transversal, and I mark these parallel, and we have 1, 2, 3, 4, 5, 6, 7, and 8. All right, let's say the measure of angle 3 is 55 degrees. Okay, angle 3 is 55 degrees. Can you tell me the measure of angle 8? So 3 and 8 are what kind of angles? They're supplementary because they're same side interiors, right? These are same side interior angles. So they have to add up to 180, okay? And if you're ever not sure, if you ever can't remember, like they look pretty close and you can't tell this one's acute versus this one's obtuse, you can always draw yourself a picture of a really sharp set of angles. So like something like this, where this is angle 1 and this is 2 and this is 3 and 4. You can obviously tell that 2 and 4 are not the same, right? But 2 and 3 are vertical angles, so they would be. Just compare like that. If you draw yourself a picture, you can see in this setup that 1, 4, 5, and 7 are all going to be the same. And then 3, 2, 6, and 8 are all going to be the same. So if you ever need to, draw just a really sharp transversal coming through, and you can see a little better how they relate. So the measure of angle 8, we would say that's 180 minus 55 because they're supplementary. So that means the measure of angle 8 will be, mental math, what's 180 minus 55? 125. Okay, so 8 is 125. And I find it rather helpful to write these things in as you go. You don't have to, but I think it is beneficial. So we know this is 55, this is 125. What other angles do you know then? What's angle 1?
55.
Why? Because they're vertical angles. So 1 would be 55 because they are vertical angles. Okay, this was 125 because of same side interior angles. So this would be 55. What would angle 5 be? What's this one? 55. Why?
Because then of course I don't think.
Okay, so there's 3 ways you can come up with this one, right? You can say 55 and 5 are corresponding. You can say this 55 and 5 are alternate interiors. Or you could say that these two are a what? 180. They're a linear pair, right? So the beauty of this chapter is you have so many ways to get to where you want to get to, okay? There's a lot of different types of angles, but they show up all over the place. So we would have 55 here. What would 7 be? 55, either because those are vertical or because these are a linear pair. What would 6 be? 125. What would 4 be? 125. And what would 2 be? 125. Okay, so look at this. In this setup, we had 4 angles. Sorry, we had 8 angles, but only 2 measures, right? If the lines are parallel, you're going to end up with 55, 125, 55, 125, 55, 125, 55, 125. Okay? So just take note of that. Often, even with 8 angles, you're only going to have 2 measures. Not every time, but a lot of the time. Okay? All right, we're going to do a proof real fast. And I got 1 or 2 more for you. So here's the proof. You are given that A is parallel to B, and you are asked to prove angle 1 and angle 8 are supplementary. So let's say our picture looks like this. They told us these are parallel, so we'll mark them parallel. And then you have angle 1, angle 5, angle 7, and angle 8. Let's talk through this. What's your first step of your proof? Right, we're going to say that A is parallel to B because it's given. Okay? Because we know the lines are parallel, then we can say that angle 1 is congruent to angle 5? How do I know that 1 is congruent to 5? Corresponding angles posture theorem. You can just say corresponding angles, that's fine. Corresponding angles. Okay, that's number 2. So we know 1 is congruent to 5. What do I know about 5 and 8? They're supplementary. I can say angle 5 and angle 8 are supplementary. How do I know that?
On a straight line.
They make a straight line. They're a linear pair, right? So you can just say linear pair, or definition of a linear pair would be fine. What does it mean that they're supplementary? They equal 180. So we can say the measure of angle 5 plus the measure of angle 8 equals 180. Can you tell me why we can say that? Definition of supplementary, right? In the step before it, they told us they're supplementary. That means they equal 180. So you would say definition of supplementary angles. Okay, so I know that 5 plus 8 equals 180. And if we look up here, we knew at the beginning that 1 is congruent to 5. So what if I said the measure of angle 1 plus the measure of angle 8 is 180? How do I know that? What did I just do? Substitution. I took out the 5 and I put in the 1 because I know that 1 and 5 are congruent. So I would say this is substitution. Okay. Now they asked us to prove that 1 and 8 are supplementary. Well, we just said 1 plus 8 equals 180. So now we can say angle 1, and angle 8 are supplementary. Why? If in the step before we said they were equal to 180, that is the definition of supplementary angles. Okay, so that would be a proof proving that 1 and 8 are supplementary. Questions on that? Okay. Last 2 things. Can I move up from this? Okay. So example 3. I'm just going to show you kind of a bigger version of what we already did with this. Let's say we have 2 pairs of parallel lines. So these are parallel, and these are parallel. And I give you 1, 2, 3, 4, 5, 6, 7, 8. And I tell you this angle down here is 105. You should be able to tell me every single angle in this picture. So using alternate interiors, using same side interiors, using correspondings, using alternate exteriors, you should be able to tell me every angle. Can you tell me angle 4? Yeah, Heather. It would be 75. How do we know angle 4 is 75? What kind of angles are those? Supplementary, which is what name? They are, it's not a linear pair. Those are same side interiors, right? Because here's your parallel lines. Here's your transversal. They're on the same side of the transversal inside the parallel lines. Okay? So those are same side interiors. What would angle 6 be?
Is that 50, 75?
75 and 105. What's angle 6? not 75, 105, right? That one, you can either say these are alternate interiors, right? 105 and 6 are alternate interiors, or you can say 4 and 6 are a linear pair. They make a straight line. Okay? What's 7? 105. Why? Those are vertical angles. What would 8 be? 8 is 105. Why? It's what?
I want to say
It's an alternate interior with this one, right? Those would be alternate interiors. So you could find this first and then say alternate interiors, or these two, 4 and 8. Those are same side interiors, right? And same side interiors are supplementary. So 105 plus 1 plus 75 gives you 180. What's 1?
75.
That one's 75. Again, you could say those are alternate interiors, these two, 4 and 1. Or you could say these two are same side interiors, or you could say these two are a linear pair. Okay? Are you seeing how there's a million ways to get there? Not literally. There's a lot of ways to get there. So in this picture, I'm going to just redraw it real quick. You have 105, 75, 105, 75, and that just keeps going all the way around. Right? So even when there's two sets of parallel lines, there are still only two values for those angles when the lines are parallel. So this would be 75, 75, 75, 75, and the rest would be 105. Okay? Questions on that? All right, last thing then is this guy. Let's say we have parallel lines here. And a transversal. And another transversal. So these are parallel. And then you have an 80-degree angle. This is Y, and this is 40. How can you find Y? There's a couple ways you could go about it. Yeah, Sam.
You could find the supplement to 80 and subtract 40.
Okay, so you can look at it like this, right? These two angles here, this angle and this angle, are supplementary. So the supplement to 80 would be 100, take away that 40, and Y would be 60. Okay, so you could go that route. Anyone see another way you could do it? That's not wrong, by the way. That's the way I would do it. But there is another way. Anyone see alternate interior angles that we can use? What's the alternate interior angle with this 40 here? This guy down here, right? How does that help us? It's a triangle. So you could look at it as a triangle right here, where you have 80, 40, and 60 to make a 180-degree triangle, right? So it's up to you how you want to see that. I would do 40 plus Y plus 80 equals 180, and then take away that 120. So Y would be 60. Or you can see it as alternate interiors there. Okay? Questions? Okay, quick recap. What kinds of angles are congruent? Everything but same side. So that's alternate interior, alternate exterior, corresponding, right? The only ones that are supplementary are the same side interiors. Okay?